All right, we're going to go over the rest. If one of the 1,150, the probability that the person is a man. So we're looking either man or heavy smokers. So, and all the heavy smokers. So over here, we have the choice to go with the totals, but then we have to make sure that we do anything twice, or we can just take all the men in our first row and then women that we haven't counted that are heavy smokers. So that's plus 39, which makes it a total of 600 out of our grand total of 156. So our correct answer would be 0.5536, rounded to 3 decimals would be 0.554. Answer D. Okay, number 7. In a fair 6-sided die, find the probability that it's either 3 or 5. So since we can't have 3 and 5 at the same time, we can simply write out the sample space, list out the 2 probabilities, and that would be 2 out of 6 or 1/3. So that would be answer D. Number 8 is asking for which of the following statements is not true. So if the probability of an event occurring is 1 point, certainly that the event will occur well between 0 and 1. So that is for sure not true. We can read through the other ones just to make sure there's no other correct answer. If the probability of A is equal to 0, then the probability of the complement is 1. That is a correct statement. Probability of an event occurring is 0, then it's improper. That is also correct. And probabilities can never be a negative value. Correct. So always keep in mind that all probabilities of values between 0. All right, number 9 is looking at a frequency table and finding probabilities. So we have the waiting times given in the customers. It says, what is the probability that the waiting time is at least 12 minutes or between 8 and 15 minutes? At least 12 minutes would correspond to over here, and between 8 and 15, or always indicates we add, but we add in such a way that nothing is counted twice. So we're simply going to add these up. So 12 plus 4 is 16, plus 4 is 20, plus 4 is 24. Their total, which is 43. Would 558 or option B. All right, moving on to the next page over here. Here we have a contingency table, number 10. And it shows us that 143 such results, including 24 false positive. Okay, so we have a total of 143 positive test results. So I'm going to put those over here. And of the 24 of them are false positive. Then we have 157 negative test results, including 3 false negative test results. Those would go over here. And then we can fill in all the other totals. So we have over here 150. Then up here we have 119. Adding these totals, we have 122 and 178. And like there's exactly 300 altogether. Okay, so what's the probability that a randomly selected subject did not use marijuana? That would be the no group over here. And our probability is there's 178 out of the 300. So making a table helps us answer a lot of these questions like that. So the 0.593. So keep that in mind when you're doing probability questions. Number 11, the probability that statistic test is 0.49. Find the probability that he will fail. Well, that's a short complement, so the probability that he fails is 1 minus the probability that he passes, which is 0.51, or option C. Okay, number 12 is similar to number 10. Again, we have totals given over here. We have wood tennis rackets and 100 graphite tennis rackets. if 7 wood and 14 graphite are defective, so we're simply going to fill those numbers in, and then find the missing numbers on our tables. Defective, and there's 86 over here. That means we have a total of 21 defective. We have 200, and that makes it 179 not defective tennis rackets. Find the probability that the racket is wood or defective. Looking for, again, our totals over here, either wood or defective, like before, or indicates we need to add. So we can add in such a way that nothing is counted twice. So we can take the 100 wood ones and add the 14 defective graphites to it. So that's a total of 100, either wood or defective. And that's the total of 200. So 114 divided by 200 is equal to 0.57 over here. So our correct answer would be C. So again, I could have given you Bravo as a straightforward probability problem, but setting up to understand the problem. Okay, number 13. Is event B dependent or independent of event A? So a green ball is drawn from a box with 5 balls and ball is drawn next and placed next to the green one. So the reason, or since we're putting these balls next to them, that means we are drawing without replacement and probabilities over here. Okay, number 14. In 1% of all voters are Democrat. If 2 voters are randomly selected for a survey, find the probability that they're both. So that means the probability that the first one is a Democrat and the second one that is 0.44 times 0.44. This is actually a binomial probability distribution. It's straightforward since we just have 2 successes, and is 0.1936, and rounded, that would be B. All right, number 15. Find the probability of correctly answering the first 3 questions on a multiple choice test if random guesses are made and each question has 6 possible answers. So we're going to get the probability of correct, and so the probability that we get the answer the first question correctly would be 1 out of 6. Or the second one correctly is also 1 out of 6 times 1 out of 6. And again, that is in itself a binomial probability distribution. However, it's straightforward because all 3 answers are correct. And the answer for that is 1 out of 216, or answer C. Match the following values as rate continuous or not a random variable. Exact weight of quarters now in circulation. Continuous random variable, it's a weight. Is measured on a continuous scale. We have half numbers. There's jumps in between, so 5, 5.5, 6, and so on. So that's discrete. And political party affiliation would be not a random variable at all. So the answer would be B, A, C. Number 17. Mars claims that 20% of its M&M candies are orange. We have a sample of 100 candies that are randomly selected. Find the mean and the standard deviation. And so the mean for a binomial distribution, because what we have over here, we have a fixed, we're looking at a sample of 100. We have the independence. One color is going to be independent from another. We the binary, because we have failure would be not orange. And then the last one is the probability of success remains the same. So for binomial distribution, we have the mean is equal to n. Standard deviation is equal to the square root of n times p times q. Okay, the n is 100. P is 20%, which is 0.2. So 100 times 0.2 is 20. And then later for the second one, so we have n, which is 100. P is 0.2, and Q, that if the probability of orange is 0.2, then the probability of not orange is 0.2 is equal to 4. So the correct number 18, a tennis player will serve 51% of the time. If she serves 9 times, what is the probability that she gets exactly 3 successful first serves? Assume that each serve is independent of another. Again, that is a binomial distribution. Number of trials, we have 9 times. We have the independence, one independent from another. We have the probability of success remains the same at 51%. And you have a successful serve or not is equal to 9. P is equal to 0.51. And we're looking for exactly 3 successes, so we can use the binomial probability formula, which 3 times the probability of success to the 3rd power times the probability of failure to the 6th power. Or we can use the binomial PDF, where n is 9, p is 0.51, and the number of successes is e. So this is what I'm going to use. Go to second bar, arrow down or up to binomial PDF. We're just looking for one probability. We have probability of success is 0.51 and 3 successes, 5, 4, 2. And B would be our correct here. Number 19 is asking us to identify whether it's binomial or not. So it says rolling a single die 53 times, keeping track of the 5s is because we have a fixed, we have 2 successes. Either you roll a 5 or you don't. It's going to be independent from another. We have a fixed number of trials, which is, and the probability of rolling a 5 remains the same. It's just 1 out of 6. So this is a binomial probability. Okay, so a couple more on the next page. Test consists of 10 true-false questions, so the probability of answering correct is just 1/2 or 0.5. To pass the test, a student must answer at least 6 questions correctly. If a student guesses on each question, what's the probability that the student will pass the test, and round to 3 decimals. So we are looking for at least 6, so that would be 6, 7, 8, 9, or 10. It is binomial distribution, fixed number of trials. We have either success or failure. We have the independence given over here, one question independent from another. And the probability of success remains the same because we have always true-false questions. So what we want to use over here is actually the complement, because we have a list of values, but they don't start at 0. So complement of x goes from 0, 1, 2, 3, 4, and 5. Because we're using the complement, we're going to do 1 minus binomial. Because there's a bunch of values, we're going to use the CDF. The n is 10. The probability of success is 0.5. And then the largest value in the complement is 5 over here. Calculating this probability is 1 minus the binomial CDF. Again, trials, probability of success is 0.5, and the largest value in here is 5. So 1 minus that is 0.377, rounded to 3 decimals.